Hello, my name is Abbas, and I'm going to be explaining both my parts. So the first thing I want to explain about is my questions, and then I'm going to be explaining my solutions, yeah? So some of the solutions I don't fully have on here, and that's due to some reasons the paper was being messed up, and yeah, but the main part is that like everything that can be done on a calculator is not here. I did that to save space, but I will be explaining it in the video what I have done, and all my final answers are here as well. Okay, so the first thing I want to talk about is part A. The question asks, determine the equation of a polynomial function, f of x, that satisfies the following conditions. And the conditions I have set are that it is a quartic function, it is a double root at x equals 2, if, it has two distinct x-intercepts at x equals -3 and x equals 1, and when f of x is divided by x plus 1, the remainder is 108. And for part B, it is sketch the function, clearly labeling all the intercepts and the y-intercept. And for part C, determine the intervals when f of x is less than 0. So essentially, I'm going to be going through all the steps I've taken and basically all the solutions for this, yeah? So the first thing, step 1, is to set up a general equation. A double root means a factor is squared. Distinct x-intercepts are single factors using the factored form of a polynomial. So over here, as you can see, I have set f of x equals a, x minus 2 squared, and then x plus 3, and then x minus 1. So we use x minus 2 squared because of the double root of 2. This, it's hard to see. The other factors come from the intercepts at at -3, and the a represents the vertical stretch of what we need to find, okay? So that's step 1. Step 1, we have our equation set, and how we set up our equation is by looking at these, right? So as you can see, it has a quartic function, it has a double root, it has the two distinct x-intercepts at -3 and -1, and this final part, we're going to be getting there. So, step 2. We use the remainder theorem to find, we use the remainder theorem to find a, basically, yeah? The remainder theorem states that if f of x divided by x minus k, the remainder is f of k. Since we are dividing by x plus 1, we know k equals -1. Therefore, f of -1 equals 108. And that's how we got that earlier. So as we can see, this is the final proof. So 108 equals a 1 minus 2 squared, bracket, -1 plus 3 bracket, and then -1 minus 1. So this goes into that, and then that goes into that, and then that finalizes into a equals -3. So that's essentially our part A done. And our part B is over here. We do that in the end. So over here, as you can see, I'm going to explain a bit more. By substituting into the remainder into the equation, we solve for a. Our level coefficient is negative, meaning the graph opens downwards. And all these things are going to help with graphing this later on. As this is pretty big, it's going to be hard to realistically graph this without a calculator. So this is more of a rough sketch. So step 3 is where we're finding the equation. F of x equals -3x minus 2, bracket, and then squared, and then x plus 3, x minus 1 as before. So this is our equation. This is how we're going to be graphing it essentially, because now we know all these things. And here's step 4, inequalities. To find where f of x is less than 0 below the x-axis, we look at the roots -3, 1, and 2. So this you can probably most likely just do on your calculator or in your head, so I didn't really put this down, but basically what you're going to be doing is you're going to be finding the equalities like we've done before multiple times. You make your graph, you basically multiply everything, and this is where you find it. So down here, this is where I finally list all the equalities. From -∞ to -3, the graph is negative. From -3 to 1, the graph is positive. From 1 to 2, the graph is negative. From 2 to -infinity, so from 2 to infinity, the graph is negative. And this is all the inequalities. And in the end, you have this here. As you can see, it starts off negative, positive, and then we also have all these listed. So -3 and 0, 1 and 0, 2 and 0, as we saw before, it's just part of this. -2, 3, -1, yeah. Okay, moving on. So part 2 is the trigonometric functions. This is something that is a really common question. It's the Ferris wheel question that we've done multiple times, even in grade 11 functions. So a rider boards a Ferris wheel at the lowest point. 2 meters above the ground. The Ferris wheel has a diameter of 20 meters and completes a full rotation every 8 minutes. So essentially, these are the parts that the student would have to do. Part A is to create a cosine function h of t to model the rider's height in meters after t minutes. So t is our minutes. Part B, a student claims that the rider, so this is a different student, right? You have to basically understand the student's claim. A student claims that the rider will be exactly at 17 meters high at t equals 2 minutes. Prove if they are incorrect or correct using your equation, right? So the equation that we make in part 1, we will be using that again in part B to prove that. And part C is to find the first 2 times in radians/minutes when the rider is exactly 12 meters above the ground. And again, we use our part A equation to help with that. So step 1, identify the perimeters. Radius, we're going to call that A is half the diameter, which equals 10. Since we start at the bottom, we can use a negative cosine graph. A equals negative 10. Then we have our vertical shift D. Radius C starting height equals 10 plus 2 equals 12. And then our period is 8 minutes. And our k value, which is basically like what we find using the period, is k equals 2 pi over period, which our period is 8 minutes. So we have 2 pi over 8, which equals pi by 4, or pi over 4. So step 2, we write our equation h of t equals negative 10 cos, and then I did this in double brackets because it was a little hard to see, but essentially it's negative 10 cos pi over 4, and then times t plus 12. Here we have our step 3. So now that we have our equation, we can verify the student very easily. We substitute in t equals 2. So h2 equals negative 10 cos pi over 4 times 2 plus 10. h2 equals negative 10 cos pi over 2 plus 12. Pi over 2 is 0 essentially. So h2 equals negative cos plus 12. h2 equals 12 meters. So therefore, we add our therefore statement. The student is incorrect. At 2 minutes, the rider is at 12 meters, which is the midline of the wheel, instead of what the student said that they would be at 17 meters. So now let's look at the last part, which is finding the 2 accurate times. So here I've drawn a little rough sketch of the radius circle and 2 of the special triangles, but essentially this is what the student will be using to find this out. So they have their part C, h of t equals 12. 12 equals negative 10 pi by 4 times t plus 12. 0 equals negative 10 pi by 4 plus t. 0 equals cos pi by 4 plus t. So we need to find out where the cosine equals 0 at exactly pi by 2 and 3 pi by 2, because those are 2 areas where cos will be 0. So then we have our final 2 things. Pi by 4t equals pi by 2, which is essentially 2 minutes. Pi by 4t equals 3 pi by 2, which is essentially 6 minutes. So our final answer would be, it would be at 2 minutes and 6 minutes.